layer, message filtering layer with the add-on protocols. So here you have to note the point how message prioritization are achieved and how small nodes can be kept from overloading with the received message. So these are the points you have to be noted very importantly. Then development of CAN. So the development of CAN began when more and more electronic devices were implemented into modern motor vehicles. Examples of such devices include engine management system, active suspension, ABS, gear control, lighting control, air conditioning, airbags, and central locking. These are the example of CAN bus system. Okay, so CAN networking system. All this means more safety and more comfort for the driver, and of course a reduction of fuel consumption and exhaust emission. So because of the advantages of CAN bus networking, that is, it will be providing more safety and comfort to the driver, as well as it will be minimizing the fuel consumption. Okay. So to improve the behavior of the vehicle even further, it was necessary for the different control system on their sensors to exchange information. This was usually done by discrete interconnection of the different system, that is point-to-point wiring. The requirement for information exchange has then grown to such an extent that a cable network with a length of up to several miles and many connectors was required. This produced a growing problem concerning material cost, production time, and reliability. So, if you want the CAN bus system to have extra features, you may be adding some NSR device to transfer the information. So, some extra discrete interconnections will be used for exchanging the information between the system, and then you may connect the system to the several miles, okay, using many connectors, okay. So that the material cost will be problem for production of this system, but time and reliability also will be extended due to additional network added to the CAN bus system for improving the behavior or features of the CAN bus system. This is before CAN. So before a CAN bus system came into the field, how it's worked, the embedded networking system worked is given here. So here, before using the CAN system, they will be using for anti-lock brake, engine control, lighting purpose, air conditioning. These are the applications of CAN system nowadays. But before that, they will be using the transmission control and active suspension control for the entire applications. Okay, the application that is ABS, air conditioning, airbags, windows, power locks, power seat. For all the application, they will be using the transmission control as well as suspension, active suspension block for the all applications. But nowadays, with the CAN system, with the CAN system, they will be using linearity, or it will be easily accessible by the all application at a same time. You see here how the networking is. It will not be in the proper structure. Okay, so somewhat collaboratively it will be networking done in the before system. Before CAN system comes to the field, they will be using somewhat a collapsed network. Okay, but here it's very clear. You can see that linearity is maintained. So the accessible time of the each and every application will be very simple. Okay, so that the speed will be increased. Okay, the solution to this problem was the connection of the control system via a serial bus system. Okay, so here they applied the serial bus system. This bus had to fulfill some special requirement due to its usage in a vehicle. with the use of CAN, point-to-point wiring is replaced by one serial bus connecting all control system. So there you will be connecting the each and every application from point to point. So one application lande innor application ku point to point it will be connected. But here you will be having the common wire serial bus system will be provided. In that you will be connected to your corresponding applications. Okay, so it will be very simple by replacing one serial bus connectors. Okay, then this is accomplished by some adding CAN specific hardware to each control unit that provides the rules of the protocol for transmitting and receiving information via the bus. So for transmitting and receiving data in the bus, you will be adding some extra specific hardware to the system with some by providing some rules for the that is protocols will be provided. This is CAN bus basic concept. So CAN is a broadcast type of bus. That means all nodes can able to hear all the transmissions. Okay, so it can be able to receive all the transmitted information. There is no way to send a message to just a specific node. All nodes invariably pick up all traffic. So every node which is present in the CAN bus system will be receiving the transmitted data information. Okay. So the CAN hardware, however, provides local filtering so that each node may react only on the interesting message. Okay, so that particular node will be responding to the incoming data only when it is interested to react. Okay, unless it will not show any response to that incoming signal or transmitted signal. See the nodes they given in the diagram. So here ABS system will use node A, EMS system going to be used node number N. So the message will be transferred through the bus system, that is serial bus commonly only. So each and every node will be receiving the same message, but the system will respond only if it needs. Okay, unless it will not be responding to the incoming signal or transmitted signal. Then basic configuration. See the diagram. So example any applications. Okay, you are using the CAN bus system. Then yellow color represented host controller. Okay, so here they given the ATC16. So controller is nothing but any of the microcontroller or microprocessor, whatever it means. CAN controller. Okay, blue color represent பண்ணிருக்கிறது CAN controller, CAN bus system controller. Host controller your microcontroller or microprocessor, whatever it means. But here they given microcontroller only. CAN transceiver. CAN transceiver means it can be able to transmit as well as receive in the same line. Okay, at a time. So this is your CAN bus, which is in the spiral form. Okay, that is CAN bus. This is the basic configuration of your CAN bus system.